All right, friends, it's your boy, Mr. Shagney, coming at you with Unit 3, Lesson 10, Changing Scales and Scale Drawings. It says, let's explore different scale drawings of the same actual thing. So 10 and 1/10 says appropriate measurements. If a student uses a ruler like this to measure the length of their foot, which choices would be appropriate measurements? Select all that apply. Be prepared to explain your reasoning. So if you notice up here, these are inches, and I notice 1, 2, 3, 4, 5, 6, 7, 8. So those are in eighths. So each one of these would represent 1/8. Then here, this are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this each tick mark is a 1/10 there. So could I get 9 1/4 inches using a ruler that's counting by eighths? I could, because I know that 2/8 is equivalent to 1/4, so that I could get, right? 9 5/64, well, I'm counting by eighths, and if I reduce an eighth, I'm not going to get a 64, so that's not an appropriate measurement given this ruler that we see here. This one, if I'm looking at centimeters here, this is like way too approximate, because if I'm counting by a 1/10 on each one of those tick marks, that's like way too accurate given this ruler to even get that answer. But I could get 5/10, right? I could get 5/10, 23 and 5/10. I could get that. This would be way too accurate as well, because remember, these are counting by tenths. So A and D are your best options for this activity, because this one is counting by eighths, this one's counting by tenths, and if you reduce those, you could, well, if you're counting by tenths, you can make 5/10, and if I'm counting by eighths, 2/8 reduces to 1/4, and so I can show that here. 2/8, if I divide by 2 and divide by 2 here, this is 1/4. I apologize, my pen is running out of ink here, so I'm going to go ahead and do this right here. All right, so that's our first activity. In the second activity, or in the second part of this, it says, here's a scale drawing of an average sixth grade student's foot next to a scale drawing of a foot belonging to a person with the largest feet in the world. Estimate the length of the larger foot. So in the previous one, for this activity, I think using a ruler, it does say estimate, so how large do we think it is? Estimate the length of the larger foot. Right, so for this, I'm going to think that the estimate of the length of the larger foot for centimeters, so if I had the ruler there, so I'm going to put a ruler here. So here's a ruler, and for this problem, I'm going to let you use a ruler. So we're going to estimate, which means that we're going to, try our best to measure this. It does say estimate, but I'm going to measure. So from there to there is about 5. And from the longest one of this is about 7.5 centimeters, and these are centimeters. So if I think, what is the scale? How much larger is that? Remember, we do actual over scaled. So 7.5 divided by 5. So 7.5 divided by 5. 5 goes into 7 one time. 2's left. Bring down the 5. 5 into 5 is 25. So about, the scale is 1.5 times larger. So the largest foot in the world is about 1.5 times larger. Now, if we were to estimate this, right, if we were to take our, if we had the ruler from the first page, if I just said, set down a ruler and approximate how long you think this foot is, we could have said, well, if I know from the first page, that's about 3.5, so I'd say that that's about, double of that. That would work out. So for that problem, that would be that example. In the next activity, we have same plot but different drawing. So we're going to use a scale of, where did my paper go? We're going to use a scale for this. So there's a couple of bits of information I need here to first give you, and then we're going to work from there. So this triangle measure has a base of 120 meters by 90 meters tall. So the base is 120, the height is 90. And so from here, we're going to scale this rectangle using different scales. So I'm going to do the scale of 1 to 50, and this is the hardest scale to use. And then we're going to use graph centimeter paper. So 1 centimeter one square of this will equal 50. And so what I need to do is I need to do a couple of problems. So like yesterday, I'm going to take 120, and I'm going to cut that into 50. And so 5 into 12 is twice. And then I'm left with that. So that's 2 4/10 centimeters. So I'm going to use a couple of those. And then I have 90 divided by 50. And then 5 into 9 is 1. And then 5 into 40 is 8. So this is gonna be my triangle here. So I'm gonna actually use a ruler to make sure this is appropriate, because I don't know if I have the centimeter graph paper. So 2 4/10 is the base, 2 4/10. It's about 2 4/10 is the base. It goes up 1 8/10. And then we're going to draw our line here, connecting that just like that. So I'm going to draw that right here. And so that is our triangle from this drawing scaled. So this one represents 2 4/10 centimeter, and this represents 1 8/10 centimeters. And it says, what is the area of the triangle you drew? So let's find the area of this triangle. To find the area of the triangle that I just made, I'm going to do the half of the base. So 2 4/10 divided by 2. That's 1 2/10. I'm going to take 1 2/10 times 1 8/10. 16, 8, 9, 2, 1, 6, 11, 2 16, and move it twice. So 2 1600 centimeters squared is the area. And I'm going to compare that to the area of the original figure, right? So I'm going to go back. So I found the area by doing this calculation here. I cut the base in half first, and then I multiply what I had left to find my area. So the area inside of this is 2 1600 centimeters squared. And then over here, I'm going to do 120. Half of that would be 60. So 60 times 90 would be 5,400 meters squared. The area we got was, I just did on that paper, so I'm going to do it again. First I did 2 4/10 divided by 2, and I got 1 2/10. I took 1 2/10 and I multiplied it by 1 8/10. Ended up getting 2 1600 centimeters squared, and I did the work on the other paper. How many square meters are represented by 1 square meters? 1 square centimeter in your drawing. So it's asking how many meters is represented by 1 full square here. And to find that, right, to find that work, we need to do a little bit of work here. So we're going to take our original area, and we're going to divide that by our scaled area. So 5,400 divided by 2 1600, right? So we're going to do that here. So 5,400 divided by 2 1600. So I'm going to move this 1, 2, add 2 zeros there. So 216 into 540. So I'm going to say that that's 2 times 12, 3, 432. Eight, 0, 108. So, and then from there, I'm going to try 5, 216 times 5, 30, 8, 10. So, and I'm going to add my zeros after that. So I brought this 0 down, so I have 2 zeros left. So it is 2,500 times larger. And so if we were to find a number that would give us that, so I need to take the square root of that to find out the side by side, we could do that. So this 1 centimeter of this would represent, so in my drawing, to get back to this, so 1 of these centimeters would actually represent an area of 2,500. Actually not 2,500, so I need to actually do something with that for a second. That would be too much, because I have a couple of those. So I'm going to take the square root of that. That's going to be a doozy for a second, so we're going to have to do quick whole thing here. We might come back to that. So this equals 50. So 50 times 50 will make 2,500, 50 squared. Right? So that's how we get that. So 50 times 50 will equal 2,500. And we know that to be true because 5 times 5 is 25, and then the zeros on the end. So what do you notice about the scales when your drawings are placed in order? So the smaller the number of meters, the smaller the number of meters represented by 1 centimeter, the larger the drawing is. So that's what I have there. So this means that 1 square centimeter would equal 50, and it would give, okay. So there's all the work for this thing here. So we started with this triangle, we scaled it down to make this triangle, we compared their area, we took the square root to find out how many square meters are represented by 1 square centimeter in your drawing. Found that to be 50, and then from there we found that the smaller the number of meters represented by 1 centimeter, the larger the drawing is. So from this we're going to have multiple triangles, so I did the hardest one that we could possibly do, and then tomorrow we're going to explore what happens with the other triangles so that we can see all together. So I'll try to play this video to help you make sense of this, and then from there we will scale the triangle differently. And our last activity for tomorrow is, it says a new drawing on of the playground. So here's a scale drawing of a playground. It says the scale is 1 centimeter to 30 meters. And so we're going to have to make a scale drawing here. So it says 1 centimeter to 30 meters. That's what this is. And it says make another scale drawing of the same playground at a scale of 1 centimeter to 20 meters. So what I'm going to do here is I'm going to measure these sides in centimeters, right? So, and I'm going to try my best to approximate those as best I can. So that looks about to be 7 8/10. This is 3 4/10. Three and 4/10. And then from there to there, it's about 5 6/10 centimeters. So I'm gonna make a scale drawing of this where 1 centimeter is 20 meters. And so this scale, we know that this one is smaller model than this. So we need to find the relationship here. To find the relationship between these two, I know that 1 centimeter to 30 meters would be one relationship. And then I have some number over 20. So I'm going to multiply, this is 20 equals 30x divided by 30. And so this x equals 2/3. But that's from, that's if we're starting with that and going to a new drawing is 2/3. So we need to do the reciprocal of that, which would be 3/2. So 3/2 would be, or 1 1/2. So what I'm going to do is my scale factor making the new one is going to be 3/2 or 1 1/2. And so I'm going to take these numbers. So if I multiply 7 8/10 by 1, I'm going to get 7 8/10. So I know the bottom of this should be 7 8/10. I'm going to go ahead and draw that, 7 8/10. And then I know that I need to do half of that. So half of 7 is 3 1/2. And then half of 8 is 4/10. So 1, 2, 3, 4. So this one is going to be, 3 9/10. So I'm going to add that to this line here, 3 9/10. And so the total line here is going to be 7 8/10, and I know that that's not perfect. 7 8/10 plus 3 9/10. That's 17, 10, 11. 11 7/10. That's my base, centimeters. And then the height of this is going to be 3 4/10. So I'm going to go 3 4/10. I'm going to line that up, draw my line. Half of 3 is 1 1/2. And then half of 4 is 2, so this is going to be 1 7/10. I'll take my line and go a little bit further here, and then so that one's going to be, we have 3 4/10 plus 1 7/10. It's 11, 3, 4, 5, 5 1/10. 5 1/10 centimeter. Then this one is also going to be 5 1/10 because they're on the same, they have the same number. So over to 5 1. This is just me doing some thinking aloud. And then 5 6/10. So now I'm at least going to go 5 6/10 here, which is that. And then half of 5 is 2 1/2. And then half of 6 is 3/10, half of 6/10 is 3/10, so 1, 2, 3, so that is 2 8/10. What should connect? I want to make sure I connect those lines there, and I think I'm going to be off a little bit. That's okay. So this is 5 6/10. Plus 2 2.5 plus 3 is 2 8/10, so 14, 7, 8, 8 4/10. And so that's kind of how you find that, thinking through the mathematics of that. This is also 5 1/10 at the top. And this should be a larger scale drawing, so it should be 1 1/2 times larger, because the scale factor going from this one to this one would be 1 1/2 times 1 1/2. How do the two scale drawings compare? So the new drawing is larger. When 1 centimeter represents 20 meters, it takes 1 1/2 centimeters to represent 30 meters. So the length a measure in measures on the 1 centimeter to the 20 meter scale are 1.5 times as long. And the area measurements are 2 25/100 times as large, because we can do 1.5 times 1.5, and that equals 2 25/100. Right, so that's our lesson for tomorrow. I look forward to seeing you then.